Welcome back to our discussion on for loops in Java. In the two previous lessons, we examined the for loop and how to use it effectively. This lesson explores nesting for loops inside other for loops. After completing this lesson, you'll understand how to write nested for loops and how they work. You will also understand how to use a common variant of nested loops called a triangular loop nest. You will then be able to apply these concepts to solve problems that require these principles. Finally, you'll be able to identify some common problems that can occur with nested for loops in Java. So, let's get started. To motivate the topic of this lesson, let's consider the task of printing a multiplication table of the integers 1 through 10. Such a table has the numbers 1 through 10 heading each row and the same numbers heading each column, and their intersection in the table contains the product. Here's an example of the output we wish to produce. Notice that there are 10 rows of data, and each row has 10 numbers that are printed. To get the columns to line up, we will print a tab character after each number as we print the numbers across the row. Let's start by writing a for loop that executes 10 times. Here, we have a loop that iterates I from 1 to 10. Now, when we add code to the body of this loop, we can add any kind of statement we wish. It could be conditional statements, method calls, or more interesting to us right now, it could be another for loop. If we add a for loop inside another for loop, we need to use a different variable for the loop counter. Otherwise, the loops would interfere with one another. In this example, we have added a for loop that uses a loop counter variable j. When discussing these loops, we will distinguish them by their loop counter variable. For example, we will name the outer loop the I loop and the inner loop the j loop. When loops are placed inside other loops in this manner, we call them nested loops. In this case, the j loop is nested inside the I loop. So what will actually happen when we execute this code? It seems difficult at first to keep track of all that is going on. In this example, the outer I loop will execute 10 times, for I starting at 1, while I is less than or equal to 10. On each of those 10 iterations of the outer I loop, all the statements of its body are executed. That includes the inner j loop. That means the inner j loop starts all over again, setting the loop counter variable j to 1 and repeating its body while j is less than or equal to 10. Thus, the inner j loop executes 10 times for each of the 10 iterations of the outer I loop. As a result, the print statement in the j loop is executed 100 times. Now, let's consider this slight variation to our loop nest. In this code, instead of the inner loop executing while j is less than or equal to 10, it is executing while j is less than or equal to the loop counter variable I. Since I has a different value on each iteration of the outer I loop, the inner j loop iterates a different number of times. When I is 1, the j loop iterates only once. When I is 2, the j loop iterates twice. As a result, the number of values printed on each line grows as the value of I grows. We see one multiple printed on the first line, 2 multiples printed on the second line, all the way down to 10 multiples printed on the 10th line. Due to this triangular pattern of the iteration space, we call such nested loops triangular loops. Now, what if we wanted a different triangular portion of our multiplication table? In this case, we want to get the values above the diagonal, with 10 multiples on the first line, all the way down to only 1 multiple on the 10th line. It appears we simply need to make the inner j loop count down from 10 to I. This j loop will execute 10 times when I is 1, and it'll execute 9 times when I is 2, down to only executing once when I is 10. Unfortunately, this also changes the values of the multiples being printed. So we get the correct iteration space, but not the correct values, as can be seen in this slide. There are a couple of ways to fix this so that we keep the same iteration space but get the correct values of the multiplication table. One way to fix this is to change the j loop back into a loop that counts up from 1. However, we change the j loop limit such that it is smaller on each iteration of the I loop. We accomplish that by subtracting the value of I from a constant. This triangular loop nest will result in the correct values being printed above the diagonal. Next, we will consider drawing figures on the screen made up of only ASCII characters that appear on a keyboard. We call this ASCII art. This is a great way to exercise writing nested loops of different types. There is one guiding principle for creating such art. The outer loop controls the number of lines to be printed, while the inner loops control the contents of each line. This is just what we saw with the example of printing different portions of the multiplication table. For our example, let's consider the problem of drawing an equilateral triangle made up of stars. Here we see two examples, a size 4 triangle and a size 6 triangle. Notice how each side of the triangle is made up of the same number of stars, and how the star at the top of the triangle is centered over the base of the triangle. To draw such a triangle given a specified size, we would need an outer loop to control how many lines get printed. We would want this loop to iterate for size times. Then the body of this loop will contain a nested loop to print the correct number of blanks or spaces so that each line is correctly indented. Since the amount of indentation changes on each line, this will need to be a triangular loop. We then need another loop to print the stars for that line. Since the number of stars increases with each line, this will also need to be a triangular loop. So we start by reading the specified size of our triangle. We then create the outer loop that will control the number of lines printed. Here, the I loop starts at 1 and continues until it exceeds the specified height. Next, we create the inner triangular loop that controls the printing of the spaces that produces the desired indentation. Since the number of spaces decreases as we print more lines, we will use a loop that counts down. Conversely, we could have written a loop that counted up but iterated fewer times by subtracting the value of I from the value of height, similar to what we saw earlier in the triangular multiplication table. Next, we create a separate triangular loop that controls the printing of the stars, with 1 star on the first line, 2 stars on the second line, etc. And after our row of stars are printed, we then print a new line character to end the current line. Finally, before closing, let's discuss 2 common errors that people make when they create nested loops. The first problem occurs when the test expression of the inner loop accidentally tests the outer loop counter variable rather than the inner loop counter variable. In this example, the inner loop is testing the variable I, and since I does not change in the inner loop, the test is I less than or equal to 10 will always be true, and we end up with an infinite loop. The second common error is updating the wrong loop counter in the inner loop. In this example, the inner loop is testing the inner loop counter variable j, but is updating the outer loop counter variable I. Since the inner loop counter variable j is not updated, this will also result in an infinite loop. This lesson explored nested for loops and showed examples of using them to write more complex Java programs. Now that you've completed this lesson, you should understand how to write nested for loops correctly and how they operate. You should also know how to write triangular loop nests, as well as be able to apply nested loops when required and identify some common problems that can occur when these types of loops are used in Java. With your increased knowledge of iteration using for loops, you've added to your growing ability to write Java programs in Android. Consider trying some of the code walkthroughs for further practice.